Hey everybody, this is a solution to day 1-6, question 15. I'll give you a moment. You've read it, you've tried it. I want to jump right in. As you're working your way through this, if this is the sort of thing that you're kind of considering as, what do I have to calculate? Do I need to calculate something? Do I have to solve something? I might argue you don't. Really what you got to do is you got to think through maybe logically. All I'm going to do is I'm going to deal with the fact that the degree of the divisor is 2. So if I went back up to my original expression that I just boxed in red there, with something kind of along the lines of, I don't know what f of x is, but you're telling me that my divisor is degree 2. So let me just write in the most generic quadratic divisor. Make sure that 2. I don't really know what q of x is, the answer I get when I divide. But the problem tells me the remainder does not equal 0, so I have something down here. So the question asks, what are the possible degrees of r of x? Well, this is where we need to reason some stuff out. If we are working our way through, and you're kind of considering that you have a degree 2 divisor, then when I go through and I divide, I have to remember that my remainder has to be always a lesser degree than my divisor. Otherwise, I could have divided out more. So, as an example, if my r of x was degree 2, and I know that that's sloppy writing, r of x equals 2, but that idea, then if when I went and I divided by my quadratic here, and I got some answer of how many times I can multiply that by, if my remainder was still a quadratic, and I'll just simplify it rather than ax squared to just x squared, I'm hoping we can see we didn't multiply it by enough. We could have taken out more in that division process. That only when our remainder is a lesser degree than our divisor. So the problem tells me that r of x cannot equal 0. So my only choices are that r of x has to be degree 1. Has to be. Now, if that stipulation in green was not there, then it is possible that r of x could be a degree of 1 or 0. Maybe when I divide by that quadratic divisor, it goes in an even number of times. There is no remainder, therefore remainder is 0. But up in the problem, that has ruled that out, so I have to be degree 1. Okay, if we pattern it out real quick, if I change the question and I said to you, well, hey, wait a sec. What if the degree of the divisor is 5? Well, then we know that the remainder happens to be degree 4, 3, 2, 1, or 0. The problem tells me not 0. It's got to be the others. Okay, I'm hoping that clarifies problem 15 and helps you through your practice. Okay, best of luck with the rest.